In this lesson, we want to take a closer look at aquifers, the underground features that supply drinking water for millions of people every day.
After the lesson, you'll be able to describe two types of aquifers and identify some of the common materials that make up aquifer systems in the U.S.
Let's start with a definition. An aquifer is an underground body of rock or sediment that serves as a storage reservoir for groundwater.
Aquifers are made up of materials that contain interconnected spaces. These spaces are essential as they can both store water and let it easily flow in and out of the aquifer. As we will see, depending on where you are located, your local aquifer may be composed of different types of rock or sediment.
The opposite of an aquifer is a confining unit. Materials such as clay have poor porosity and/or permeability and will restrict or prevent the flow of groundwater. Layers of clay, shale, or other low permeability materials act as a barrier for groundwater flow and may separate aquifer systems. Water may still pass through these layers, but much more slowly than through the aquifer.
Most aquifers fall into one of two types. Unconfined or open aquifers are directly connected to the Earth's surface. In contrast, confined or closed aquifers are separated from surrounding rock layers by confining units above and below the aquifer. Let's take a closer look at each type.
Unconfined aquifers are supplied by water that filters down from the land surface. It's much like pouring water into a beaker of gravel. The water easily flows between the grains, and the level of water in the beaker is dependent upon the water supply. The water table represents the upper surface of an unconfined aquifer.
The greater the water supply, the higher the elevation of the water table. We expect the water table to show some short-term fluctuations related to storms and longer-term seasonal variations.
There is also the potential for a decline in the depth of the water table if groundwater is consumed more rapidly than it's replenished.
Water doesn't enter confined aquifers as easily as it does an unconfined aquifer. Water can just trickle down into the unconfined aquifer, but the underlying confining layer prevents groundwater from continuing its journey directly into the confined aquifer from above.
Instead, these confined aquifers are supplied by streamflow or precipitation in places where the aquifer materials crop out at the surface.
Groundwater in the confined aquifer is under pressure from water upslope in the same layer. This can produce what are known as artesian wells that shoot the pressurized water upward, no pumping required.
This colorful map shows the most significant aquifer systems in the U.S. The type of aquifer present under different locations is largely a consequence of the local geology. Let's take a look at some of the most common types of U.S. aquifer.
The most common unconfined aquifers are piles of sand and gravel typically found within 100 feet or less of the surface. These shallow aquifers can provide an abundant supply of groundwater, but may also be susceptible to contamination.
Many of these sand and gravel deposits were left behind by glaciers that covered the northern states during the last ice age.
In comparison to loose sand, sandstone has been compacted and its grains have been cemented together. This reduces the porosity of the original sand deposit, but it still represents a pretty good choice for an aquifer in many locations.
Sandstone aquifers are common in western states, parts of the Midwest, and throughout the Appalachians. The line on the map represents the southern edge of glacial deposits. North of this line, sand and gravel are more likely to serve as the primary groundwater source than sandstone.
Limestone can be dissolved away, leaving large spaces to fill with groundwater. Aquifers composed of limestone are not as common as some others, but can be found in states like Missouri, Ohio, and Florida.
Groundwater may enter the carbonate aquifer system in Florida in its unconfined state, where it is buried at shallow depths, and then may flow downslope through connected fractures and cave systems to where it forms a confined aquifer further south.
Finally, igneous and metamorphic rocks should not be good aquifers as they contain no natural porosity or permeability. However, these rocks are often fractured during their formation or during episodes of tectonic activity.
Fractured lava flows in Oregon, Washington, and surrounding states, and fractured crystalline igneous and metamorphic rocks in the Appalachians are two examples of these rock types that can result in productive aquifer systems.
So water flows through the majority of U.S. aquifer systems by way of natural porosity, dissolved spaces, or sets of fractures. Sand and gravel may make up simple unconfined aquifers, but confined aquifers can contribute to groundwater supplies in many locations.
These are our learning objectives for today. How confident are you that you could respond to these statements?